Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 2 for this week. This is going to be a short one and sort of hopefully a fun one. But in the interest of time, I wanted to make it as simple as possible as opposed to compared to the one on Monday, which was incredibly complicated. So let me go on ahead and put myself down here in the corner, and we're going to be taking a look at the normal temperatures, which I prefer to call the 30-year average. And these are updated every 10 years. So right now we're using the period 1991 to 2020. And those are the normals we will use until we complete the year 2030. And then it'll go from 2001 to 2030. And so in early 2031, those new normals will come out. And 30 years is generally looked at as a period of time where you can assess whether or not the climate is changing or not, okay? And this goes way back before the issue of climate change. It's just that that period of time gets rid of a lot of the noise, okay, where you can have, a cold winter or a hot summer or whatever. And this is a long enough period of time so you can really take a look at the long-term trend. So the red line there is the normal high, the 30-year average for the max. The gray is the mean temperature, and the blue is the low. And there is a smoothing process that the folks at NOAA use, because if you didn't do that, even if you're looking at a 30-year period, there's still going to be a few jigs and jags here and there, just because there are a few days that act a little funkier than some other days, okay? And so there is a smoothing process that goes into play. And if you take a look at all of the normal highs and lows and so forth, the lowest normal high occurs on a period of time that is centered on January 15th, and the highest normal high occurs on July 14th, which I believe is Bastille Day, if I'm not mistaken. But anyway, you may be thinking to yourself, well, wait a minute, the shortest day of the year is the winter solstice, which is like December 21st, and the summer solstice is on or about June 21st, so why is this offset about 3 to 4 weeks from those? Well, the answer to that is fairly simple, is that after December 21st, there is still more radiation leaving the Earth to space than there is coming in from the sun. And so if you sort of look at it like a bathtub analogy, where the faucet is turned all the way down on December 21st and the water level is fairly low, and then you begin to turn the faucet up just a little bit after December 21st, but there's still more water going out through the drain than there is coming in from the faucet. So the water level continues to lower until about the middle of January, and then the faucet strength is hard enough or significant enough so that it overcomes the drain and the water level begins to increase. Same thing after June 21st, you're beginning to turn the faucet down, but there is still more water coming into the bathtub than there is leaving the drain, so the water level actually rises, and then after July 14th, then the drain takes over and the water level begins to drop. So that's why you have that 3 or 4 week offset there from the shortest and longest days of the year to the coldest and the hottest days of the year. Now, I thought this would be maybe a little bit fun. And for those of you that are mathematically minded, we got into all this calculus on Monday. If you have a graph, a function, if you will, and then you take what's called the first derivative of that function, that is basically the slope of that line at any point along that graph, okay? So that's what this is, okay? This is the rate of change of those normals, okay? And the x-axis there at the bottom are the weeks of the year, okay? So and actually there's 52 there. It's just that my font was too big to sneak in the 52. So what I did here was that the dotted blue line is what we call a polynomial. And so in a perfect world, if you wanted everything to be symmetrical, that's what this curve would look like. But it's not, okay? And I can't explain this. I'd really have to go back and dig deep here to figure out why this is happening. But from March 21st or 25th to April 8th, then there's a little bit of a spike here, okay, where the rate of change of the increase of the normal highs peaks at about, I believe it's about 2.3 degrees, okay, per week, okay? And then it slows down a little bit, only to have a secondary peak of 1.9 degrees, and that occurs from June 3rd to June 10th. And so, to be perfectly honest with you, I do not know why there is a double spike like that. I found that very, very interesting. And then going down the sliding board on the other end, there are a few deviations, but nothing like what we see up here. Okay, you can see one period of time here where it's cooling more rapidly than it was before, and here it slows down a little bit. But basically, it's behaving a lot more predictably here than it is up in here, okay? And then if you really want to get picky, there's a little thing here where it is rising more slowly than it is anywhere else on either side of it. So anyway, I just thought that was interesting, that the world is never quite as simple and smooth as you think it is, or I think it is anyways. So that is a detailed look, somewhat detailed look at the 30-year averages and why they do what they do and why I don't know what they do in this last case. So that is bonus weather video number 2 for this week. The next one, the third one, the final one of the week will be coming up Friday. And of course, the next daily weather update coming up tomorrow. So you all have a great Wednesday evening, and we'll talk to you soon. See you later.